Alright guys, on these where you've got a fraction, the first thing I would do is try to reduce the fraction on the top and the bottom. But if you look at 32 and 25, nothing goes into both of those, so we can't reduce it. The next thing to do is just simplify the top and bottom separately. So before we look at the top, I just want to look at the bottom real quick because it's pretty easy. If you just think about the square root of 25, that's 5. So we've already taken care of that. So I'm going to come down here and look at 32x squared y. Again, we're going to do them separately. So I'm going to look at square root 32 first. So if you remember that table that I pulled up on one of the other videos, we need something that has a square root that goes into 32. Now 4 goes into 32, but we need the biggest one, which is 16. So I'm going to split 32 into the square root of 16 times square root of 2, because 16 times 2 is 32. Then we know the square root of 16 is 4. So that gives me 4 square root 2. So I'm going to put that up here on the top of the fraction. I'm going to leave some space because we know we might have some variables. Okay. And then I'm going to go to the x squared. So the way you do the variables is you take the power, which is 2, and divide it by the root. And remember, a square root is understood to be 2. So for the square root of x squared, I'm going to take this 2 and divide it by this one, which is understood to be a 2. Now 2 goes into 2 one time with none left. What that tells me is 1x comes out and there are 0 left inside. Okay, so we're going to put an x on the outside. We don't have any left on the inside of the radical. Last, we look at the y. So if you look at the y, the power on it is a 1, and we remember that this is a 2. So if we look at square root of y, this is 1, this is 2. If I try to take the power, which is 1, and divide it by the root, which is 2, of course 2 does not go into 1. What that means is you can't take any out. And so the y is going to stay underneath, and that is your full answer. Let's do another one. Similar, because there was another question. So let's say we have this cube root 135 a to the 4th b to the 6th over the cube root of 5a. So again, what we want to do with these fractions first is see if we can simplify them. So if you look at 135 and 5 here, okay, these are both under a cube root, so we can divide that out. So 5 goes into 135 27 times. Okay, so I know that I can simplify that or reduce that just down to 27. Then we're going to use our rules of exponents with the a's. So I have 1a down here and 4 on the top. Remember that you subtract those or cancel. I cancel one of these with one of those, and that leaves me with a to the 3rd. So that's going to go underneath. And then we still have that b to the 6th. Okay. So now we've simplified it some. And the next thing we're going to do is look at each part separately to see if we can simplify further. So first, if you look at the cube root of 27, the cube root of 27 is just 3. Okay. Nothing left underneath, it's just 3. Then we're going to take our exponents and do the power divided by the root. Okay. So if we look at the cube root of a cubed, we take 3 divided by 3. It goes in one time with none left. Okay. That tells me that 1 comes out and there's none left inside. So I have an a that comes on the outside. Next, we're going to look at this b to the 6th. Okay. So I've got the cube root of b to the 6th. And I'm going to take the power and divide it by the root. So 3 goes into 6 2 times with none left. That tells me that 2 come out and there's still none left inside. So we have b squared there, and there's none left inside. There's nothing left in the radical. And so your final answer is just 3ab squared.